Exercise 7.5, question number 15. In this, we have to integrate the rational function 1 over x raised to 4 minus 1. So let us solve question number 15. Solution 15. I equal to integration of 1 by x raised to 4 minus 1 dx. So we'll be doing this on a larger page. So this will become equal to, we can rewrite this as 1 by integration 1 by x square minus 1 into x square plus 1 dx. Now we see that in the denominator there are only there are two factors and they are only involving x square and a constant. So and in this case what we'll do, we'll take x square as y, let x square equal to y, therefore we'll do the partial fraction of this 1 by x square minus 1 into x square plus 1. And how we are going to do that is very important one. In all these kind of questions, when the rational function is of this kind, that is only the factors will be involving x square and a constant. So and there is no other term like x or x cube. So we'll be doing this particular method. This you have to remember. So we'll write this as 1 by x square minus 1 into x square plus 1, and that can be written as, because we have taken x square as y, so 1 by y minus 1 into y plus 1. And after that what we are going to do is we will do the partial fraction of this one. So we'll not here differentiate both sides with respect to say y. What we are going to do is simply we'll do the partial fraction of this. Now we'll go in exercise 7.5, question number 18, because it is similar to our question number 15th one. So this is our question number 18. 18th one we are having here, this 18th one, and this is a rational function, and we can see that the numerator and denominator both are expressed as factors of x square plus some constant. So this is exactly same method we will follow which we have followed in question number 15th one. So let us do 18th one, solution 18. So here x square plus 1 over x square plus 3 into x square plus 2 over x square plus 4, this whole is only 1, so putting in bracket, and so for this put x square equal to y. So we'll put x square equal to y and solve it in the same way as we have done question number 15. So putting x square equal to y, therefore we have x square plus 1 into x square plus 2 over x square plus 3 into x square plus 4, that can be written as y plus 1 into y plus 2 over y plus 3 into y plus 4. Now we see that if you multiply them all, just we can just easily see that in the numerator we will get a quadratic polynomial, denominator also will get a quadratic polynomial. That means the degree of the numerator and denominator are equal. So this rational function is not a proper rational function, it is improper. So first of all we will have to make it a proper rational function by doing long division. So that is what we'll do. So this we can rewrite as first equal to, we'll multiply it, y square plus 2y plus y plus 2 over, it will give us y square plus 4y plus 3y plus 12, and this will give us equal to y square plus 3y plus 2 over y square plus 7y plus 12. And already as discussed, we can see that the degree of the numerator and denominator are equal. What we are going to do is we are going to divide this. So we'll use the method of long division. So we just use long division method. So y square plus 7y plus 12 is going to divide y square plus 3y plus 2, and obviously if you multiply with 1 we'll get the result. So this will be y square plus 7y plus 12, and we'll do the subtraction. So minus, minus and minus, and these two will be cancelled out because they are of opposite sign. 3y minus 7y will get minus 4y, 2 minus 12 will get minus 10, and with this the division is complete. Why it is complete? Because the degree of the divisor is 2, and that expression which we are getting here, its degree is 1. So that means this is our remainder and the division is complete. So therefore we can write this as, therefore y square plus 3y plus 2 over y square plus 7y plus 12 is equal to 1 plus minus 4y minus 10 over y square plus 7y plus 12. So from the numerator we can take out minus common, and this we can rewrite as 1 minus 4y 1 minus 4y plus 10. Even if you want, we can take out 2 common, over, divide by, now with this y square plus 7y plus 12, on factorizing it will give us the same thing, that is y plus 3 into y plus 4. So we will write in that form, in the form of factors, y plus 3 into y plus 4. Or even if you write in this form, then also we can do the integration, because we know that how to integrate this. Already in earlier exercise we have learned how to solve integration of the form px plus q over ax square plus bx plus c. So that method also can be used, but here we can here we will be using partial fraction method. So we know the integration of 1, so it's not a big problem. And this second part, so this second part we'll do the partial fraction of 4y plus 10 over y plus 3 into y plus 4, and then we'll integrate by putting the value of y as x square. So let us solve this further. So let me write down this in the next page so it will be easier. So we are having this as, therefore let's write down the initial one. What is our initial function? That is x square plus 1 into x square plus 2 over x square plus 3 into x square plus 4. This is to be written in bracket. So therefore x square plus 1 into x square plus 2 over x square plus 3 into x square plus 4 equal to, and moving here downwards in this, that is equal to 1 minus, equal to 1 minus 4y plus 10 over y plus 3 into y plus 4, y plus 3 into y plus 4, and do not forget to put the brackets. So this is what we are got. Now what we'll do is, first we'll do the partial fraction of this one by seeing the table 7.2, and if you see table 7.2 you'll come to know that we can write, let 4y plus 10 over y plus 3 into y plus 4, that can be written as a over y plus 3, a over y plus 3 plus b over y plus 4. So this is what you can see by seeing the table 7.2. Easily you will come to know that which form we are applying, and now we'll just solve it. So we'll be getting, therefore 4y plus 10 equal to a into y plus 4 plus b into y plus 3. So this will give us 4y plus 10 equal to, grouping the y terms together, a plus b into y plus 4a plus 3b. 4a plus 3b. Now comparing both sides. So comparing both sides, we have comparing both sides comparing both sides we have, so we'll be had, and the coefficient of y is here a plus b in the right hand side. On the left hand side is 4y. The coefficient of y is 4, so we can easily say that 4 is equal to a plus b. Let this be equation number 1. And also the constant on the left hand side is 10 and the right hand side is 4a plus 3b. So we can say that 10 equal to 4a plus 3b. So this is what we have got. Now if we solve these two, we'll get the values of a and b. So what we can do is we can multiply the first equation with 3 and then subtract with second. So multiplying 1 with 3, multiplying 1 with 3 and 2 with 1, 2 with 1, 2 with multiplying 1 with not equation 3 is actually 3, multiplying 1 with 3 and 2 with 1, 2 with 1, we have, so what we are going to have, if we multiply this with 3, we will be getting here 12 equal to 3a plus 3b, and here we will be getting here 10 equal to 4a plus 3b, and then we will do the subtraction. So now let us do the subtraction. So this minus will come here, minus here and minus here. So 12 minus 10, that will give us 2, 3a minus 4a will give us minus a, and 3b minus 3b will cancel each other. So we will be getting 2 equal to minus a. Therefore we can say that a equal to minus 2. Now we'll put this value of suppose this is fourth one, third one. So this is third one. So putting 3 in, you can put in either in 1 or in 2. So I will be putting 1, putting 3 in 1, putting 3 in 1, we have, so we'll in place of a we'll put minus 2, we'll get 4 equal to a is minus 2 plus b. From here 4 equal to minus 2 plus b. So therefore b equal to 6. So these are the values we have got. A is equal to minus 2 and b equal to 6. Now we'll solve this further. So here we have got 4y plus 10 over y plus 3 into y plus 4 equal to a over y plus 3 plus b over y plus 4. So first of all, we'll put the value of a and b here. So therefore, four y plus 10 over y plus 3 into y plus 4 is equal to, we have got a over y plus 3. So a over y plus 3 plus b over y plus 4. Now let us see what is the value of value of a and b. So value of a is minus 2 and value of b is 6. So a equal to minus 2 and b equal to 6. That is what we'll put here. Minus 2 over y plus 3 plus 6 over y plus 4, because value of a is minus 2 and value of b is 6. Let us confirm it again. Here a equal to minus 2 and b equal to 6. Now we'll put this value of a over y plus 3 plus b over y plus 4 in place of 4y plus 10 over y plus 3 into y plus 4. So therefore we can say that x square plus 1 into x square plus 2 over x square plus 3 into x square plus 4 equal to, therefore x square plus 1 into x square plus 2 over x square plus 3 into x square plus 4 is equal to 1 minus 1 minus this 4y plus 10 over y plus 3 into y plus 4, that can be written as 1 minus 2 over y plus 3 and plus 6 over y plus 4. So 1 minus 4y plus 10 over y plus 3 into y plus 4. But 4y plus 10 over y plus 3 into y plus 4 is capital A over y plus 3 plus b over y plus 4. So that is what we have written here. And now this can be further simplified as, therefore x square plus 1 into x square plus 2 over x square plus 3 into x square plus 4 equal to, this will become, when we open the bracket, will become 1 plus 2 over y plus 3 plus 6 over y plus 4, but this minus and plus will become minus, so we'll write here minus. So now next, also if you remember that we have taken x square as y, so we, in place of this y, will put x square. So we can say that therefore x square plus 1 into x square plus 2 over x square plus 3 into x square plus 4 equal to 1 plus 2 over x square plus 3 minus 6 over x square plus 4. So let me show you that particular step which we have taken. Here in the first page, we have taken x square equal to y. So we have taken x square equal to y. That is what we are putting it again back. So in place of y, we are putting x square plus 3. Now we have to find the integration of this rational function. So just we'll integrate both sides with respect to x. So therefore we can say that I equal to integration of x square plus 1 into x square plus 2, x square plus 3, x square plus 4 dx equal to, so this side will be getting integration of 1 dx plus, this 2 is constant, so we can take it out, 2 into integration of 1 by x square plus 3 can be written as root 3 square dx, and this minus 6 again the constant, so we can write this as minus 6 integration of 1 by x square plus 2 square dx. So now we can easily integrate this and get the value of I. Therefore we can say that, therefore I equal to, now integration of 1 is x, so x plus 2, and we know that integration of 1 by x square plus a square is 1 by a into tan inverse x by a, so 1 by a, so that is 2 into 1 by root 3 tan inverse x by root 3, and we'll be getting here minus 6, same here will be applying 1 by a, that is 1 by 2 tan inverse x by 2 plus c, and this further we can write as, therefore I equal to x plus x plus 2 by root 3 tan inverse x by root 3 minus 3 tan inverse x by 2 plus c. So this is our final answer, and with this question number 18 is complete. So this is the answer of question number 18. Exercise 7.5, question number 16. So question number 16. So solution of this, let us see how we can solve it. So we are having 1 by x into x raised to n plus 1, and we have to integrate this. So dx equal to, just we will multiply with x raised to n minus 1 both the numerator and denominator. So we will be getting x raised to n minus 1 dx over, this will become x raised to n minus 1 into x. So that will become x raised to n into x raised to n plus 1. So after that, let this is our I equal to, so let x raised to n equal to t. So therefore, differentiating both sides with respect to x, will be getting n into x raised to n minus 1 equal to dt by dx, and this will give us n into x raised to n minus 1 dx equal to dt. Therefore, we can say that x raised to n minus 1 dx equal to dt by n. So putting these values in our I, will be getting, therefore I equal to, in place of x raised to n minus 1 dx, we can write, because this 1 by n is a constant that we can take out of the integration. So dt over t into t plus 1. Now we will be doing the partial fraction of this, and if you see it, it is the partial fraction which will be applying here will be of the first type. So let 1 by t into t plus 1 equal to a by t plus b by t plus 1. So this will give us on solving. Therefore, we can say that 1 equal to a into t plus 1 plus b into t, and now we'll group the t terms together and constant together. So we'll be getting, therefore 1 equal to a plus b into t plus a, and if you compare both sides, there, because there is no t terms on the in the left hand side, so that obviously means the coefficient of t is 0. Therefore, on comparing, we can say that a plus b is equal to 0. So let this be equation number 1, and constant is on the left hand side is 1, and here it is a. So we can say that a equal to 1. So a equal to 1. This is second one. So putting 2 in 1, we have, so a plus b equal to 0. So 1 plus b equal to 0. Therefore 1 plus b equal to 0, and this will implies b equal to minus 1. Now we can easily integrate. So therefore I equal to integration of 1 by n. Here we are having dt over t into t plus 1, and that we have rewritten as, in place of that we'll put a by t plus b over t plus 1. So equal to 1 by n integration of a by t plus b by t plus 1 and dt, and this will give us equal to 1 by n. If we integrate this, we'll be getting here a log t plus b log t plus 1, modulus will come, and plus c. And now let us put the value of a and b. So what is the value of a? A is 1 and b is minus 1. So therefore I equal to 1 by n. This is, a is our 1, so log modulus of t plus b. What is the value of b? B is minus 1, so plus, this is minus 1 log modulus of t plus 1 plus c, and we know that log a plus minus will be minus, so log a minus log b is log a by b, so we can rewrite this as, therefore I equal to 1 by n log t over t plus 1 mod plus c. Now we'll be putting the value of t, because our integration, our initial function was in terms of x, so we'll be writing t as x raised to n, replacing t with x raised to n. So this will give us I equal to 1 by n log modulus of x raised to n over x raised to n plus 1 plus c. So this is our final answer. So this is the answer of question number 16. Now exercise 7.5, question number 17, 19, 20, 21, 22, 23. They all will be for self-trial. So question number 17 is very simple. Already hint is given to you. So sin x, put sin x to t, and here when you put, we'll be getting 1 minus integration of, here we'll be getting 1 minus t, and this will become 2 minus t, and difference of sin x is cos x dx, so it will become dt. So we'll be getting here dt over 1 minus t, 2 minus t. So it's very simple. Then we'll be using here our partial form 1, and we'll get the answer of this. So 17th one, what we will be getting on putting sin x to t, that is cos x dx, become dt over 1 minus t into 2 minus t. So this 17th one you will try on your own. Then we have question number 19. In question number 19, before that, question number 17 will be for self trial. Hint is already given to you. And question number 19, put x square equal to t and then solve it. So this will become t plus 1, this will become 2 t plus 3, and the numerator will be getting 2x dx as dt. So that also we can integrate. And question number 20 also you will be doing on your own. Question number 20 is also for self trial. So the hint is that multiply numerator and denominator both by x cube. Multiply numerator and denominator by x cube. When you multiply this, you will be getting here x cube over x raised to 4 into x raised to 4 minus 1. Then put x raised to 4 as t, and you will be getting the answer. Then question number 21, hint is already given to you. And then question number 22, again, that is the first form of partial fraction. So question number 22, first form of partial fraction. First form of partial fractions. If you see the table 7.2, you will come to know that is the first form. And this question number 23, that is the type 5. So question number 23, that is of the form px plus q over ax plus b into say px square plus qx plus r, where px square plus qx plus r cannot be factorized further. So it is of that form. So question number 3 is type 5. So that is fifth form of partial fraction. Fifth form of partial fraction. So all these questions you have to do on your own. They are for self trial, so do them. So they all are for self trial, that is you will try them on your own. And so with this the exercise 7.5 is complete.